Okay, guys, welcome to Fullstack Academy. I want to introduce to you Gayle Laakman McDowell. Gayle is the author of Cracking the Coding Interview and the newly released Cracking the PM Interview, also, both of which are awesome books and books that we use a lot here at Fullstack Academy. We're extremely excited to have Gayle here and share her kind of insider tips on cracking the coding interview. So I'll let Gayle take it from here. But welcome to Fullstack and enjoy the talk.
Thanks so much, Nimit. So as Nimit mentioned, my background is I was a software engineer at Google and also worked at Microsoft and Apple. And Google, I was actually on the hiring committee, which is basically the committee of people who decides who actually gets offers. So at Google, all the interviewers write up feedback, and then that goes to a hiring committee who makes the actual decision. And then Yahoo and Facebook and some other companies have done similar things. So I served on the hiring committee for a few years, and then founded Career Cup, which is a site and forum around interview questions for tech companies, and then wrote 3 books: Cracking the Coding Interview, which I know a lot of you guys know, Cracking the PM Interview for product managers, and then the Google Resume, which is more of a comprehensive how to get a job in tech book. And then I also do consulting for companies going through acquisitions to help them prepare for those acquisition interviews, and then also do consulting with companies to help them actually work on their interview process. So without further ado, my slides, because people always ask about this, they are online already. What I do is I post a more, basically I take this, I have the slides that I trim down for this, and then what I actually post online is actually a more expanded version. But you can find it, so you won't be able to, if you try to do it now, you won't perfectly follow along, but it'll be pretty close. But you can click, go to technologywoman.com, which is my blog, go to speaking engagements, and then just search for a master slide deck. Okay, so a typical interview, typical technical interview is primarily technical. A bit of chit-chat at the beginning about your resume, a bit at the end where, which is usually about, do you have any questions for us, allowing you to ask questions about the company. But the bulk of it is technical. And when you're asked, so if you're asked, say, coding an algorithm problem, the evaluation and what I've seen really drives who gets an offer tends to be about problem solving and coding skills. Personality, and then I'm talking about the big tech companies like Google, Facebook, Amazon. It's primarily coding the algorithms that gets people rejected. Personality or culture fit matters, but usually more at smaller tech companies or sort of B-tier tech companies. It also matters in biasing interviewers. So an interviewer who really likes you is more likely to kind of want to perceive your technical skills as better. But people rarely get, at the biggest, the top tier of tech companies, rarely get offers or get rejected because of their personality, with the exception of arrogance. Arrogance is a one time where you'll have people who are very skilled getting rejected. Experience, likewise, it's more of a filter in the resume process who actually gets interviews than is in actually getting an offer, which makes sense because they're using the interview to test your technical skills. Rejecting you because you didn't have the right experience, didn't have enough experience, it's a little bit weird because that really should have taken place before getting an interview. With that said, what they're doing here is they're testing with these sort of coding and algorithm challenges. They're trying to test your aptitude, not your knowledge generally. So the top tier of tech companies are less likely to ask questions about, what does this keyword mean in Java? They're more likely to focus on having you solve a problem you haven't seen before. Because they want to know, not do you know the answer to how to write this particular algorithm, but they want to know how good are you going to be at solving algorithm problems you haven't seen before. So it's about aptitude, not your knowledge. And the way that you're evaluated is something that a lot of people don't really truly grasp. So what happens in these interviews isn't that, when I was in an interview at Google, nobody gave me a list of questions and told me, go ask this question and this is what doing well means in this interview. Nobody gave me that information. So I have to kind of figure it out for myself. And the way that I do that is I ask a bunch of people the question. So, I ask you the question, and you the question, and pretty soon I get a feel for, hey, this is how long most candidates are taking. So when you take really, a lot worse than that, then you need a lot more help for me to solve it. That's not a good sign. Or you do a lot better than other people, and that's a very good sign. So it's not the evaluation is a relative evaluation. So I evaluate you relative to other candidates on the same question. that I've personally seen. I don't, because I don't know what everybody else is doing. So that's a very important thing to grasp. So, and the reason why, I get these questions that show that a lot of people don't understand this. People will ask me things like, oh, I got I was asked 2 questions, but I only solved one of them. I wasn't able to finish the second one. Is that a really bad sign? And it's impossible for me to answer because unless I know what those questions are, I can't really say whether that was good or bad. A lot of my interviews, the candidates who get offers needed, I tend to ask harder questions. So the candidates who get offers or get recommended for offers from me tend to finish maybe one problem with a good amount of help. But on easier questions, if an interviewer is asking you easier questions, you might get through 2 or 3 or more if they're really easy questions. So it's very relative. So I evaluate you relative to everybody else on the same problem. So that's how it works for sort of the biggest tech companies. At startups, it's a lot more variable. They do look at coding and intelligence or problem-solving skills. They also often want to see what technologies you know. So a lot of times they want you to know that you can hit the ground running, that you can walk. If they're using Python, they want you to know Python. They often want entrepreneurial skills or some sign of that you have initiative, that you will do whatever it takes to get the job done. They also tend to focus more on culture fit, just because it's a much smaller company. Those team dynamics really, really make a difference, particularly when things are changing very rapidly. But it's very variable. So what I recommend if you are interviewing with startups, ask the recruiter what kind of questions the startup tends to ask, but take that information with a grain of salt. Because a lot of times recruiters will sort of tell you what they think the company should be asking, but not necessarily what the company is actually asking. So they might tell you that the company isn't big on algorithm problems, it's much more about technologies or vice versa, but individual interviewers might do one versus the other more. So, but it's a good rule of thumb to ask interviewers. Or the other rule of thumb is to look at where a startup's first employees came from. The first employees tend to guide the interview process. So if you notice the earliest engineers worked at like Google and Facebook, the interview process is likely to reflect the Google and Facebook style questions. Okay. So we move on now I'm going to talk a little bit about resumes and sort of how you get even selected for an interview. And then I'm going to talk, mostly in this talk about the interview process. So a little bit more about behavioral stuff, but most of it's going to be about the technical side. So the way you get an interview, basically it's a matter of your background and then writing a great resume that portrays that background. By far and away, if you guys are kind of trying to level up your career, you're at maybe a B-tier tech company, or maybe you're at a non-tech company, so a lot of financial firms, and you really want to figure out how can I get an interview at Google, how can I get an interview at Facebook? By far and away, the best thing you can do to really take that level up and get into the sort of the more selective core hardest core tech companies, the best thing you can do is projects. And this is actually really cool because a lot of the biggest tech companies will look the other way even on CS degrees. They're great, but they aren't everything. The best thing you do is do projects, and you can make a huge difference in the quality of your resume in just 1 or 2 months. Spend a couple weekends building some really cool projects, participating in some hackathons, and put these things on your resume, and you can be perceived in a very different way. So if there's one thing I want you to take away as far as how do you get an interview, it's projects. Start doing some projects. It doesn't, a lot of people ask me, should I do open source? Should I do mobile? Should I do a web project? There's slight little preferences. Some companies really like open source. Some companies, if you're applying for mobile tech companies, mobile's a little better. But honestly, in the vast majority of cases, it doesn't matter that much. Just coding is coding. We want to know that you are excited about building code and that you're learning, you're doing things. So it doesn't, focus first and foremost about getting that coding experience. If you can make it extra relevant, that's great, but really coding is an important thing. Okay. So now the resume part. The key concept that people need to understand in resumes is how little time resume readers actually spend on resumes. So what happens is basically we pull your resume out of Giant Stack. We do a quick spot check, company names, schools, etc. We skim the bullets really quickly to see if you've had an impact, have you written real code, and then we make this snap judgment. If you're lucky, someone might spend as much as 30 seconds on your resume, but 15 seconds is probably actually more realistic. So 15 seconds, even if your resume is only one page, is not enough time to actually read your resume. It's a quick glance. So when you're designing your resume, you need to think about, how do I make the best parts of my resume, the best parts of my background, stand out in a quick glance? Make sure that people won't miss the best stuff. So here's a, yeah?
They don't use some kind of automated system to do pre-screen?
So the question was, do they use an automated system? Some companies do, but usually not exclusively. Part of the thing is that, particularly when you're talking about Google and Facebook, it's very difficult to know what you would screen for. So if I were at Google and I wanted to use an automated resume thing, what would I be looking for? I mean, skill in a particular language, but we don't care about what languages somebody knows, really. Schools, maybe, but everything that I would screen for as a resume reader would be stuff that if it was on your it would already be on your resume, right? It'd be like, maybe I'd search for people who went to MIT and CMU. That'd be nice. Maybe I'd look for people who worked at other big tech companies. But looking for particular keywords like languages, it happens, but most of the resume selection is really more manual. There's honestly just aren't great keywords to search for software developers, because they aren't that at the top tier tech companies. They really aren't that language focused or keyword focused. Okay, so this is what a CS resume should basically look like. So a couple things you'll notice here. The general rule of thumb is one page only. People tend to be a little bit more lax. If you have more than 10 years of experience and multiple jobs that are relevant, a little bit more laxed on this. But generally speaking, you will actually portray yourself with actually much more experience, much more interesting experience, if you keep your resume short. And in fact, if you look at most resumes that I get that are long, tend to be people with actually less experience, because they think they want to throw in everything they can to make themselves look really impressive, and it actually works against them. Because if you think about what you would have, imagine you create two versions of your resume. One's one page and the other one's 2 full pages. The stuff that's on the 2-pager but not the 1-pager is basically the worst half of stuff, right? If there was a better half, we would have made onto the 1-page resume. So when you make this comparison, 1-pager or 2-pager, and I randomly select bullets from each one of them, I'm going to see more interesting, impressive accomplishments on the 1-pager resume than the 2-pager. A 2-page resume actually drops the quality of content on your resume. So so that's one big problem with making a longer resume. The other problem is that people will just disproportionately focus on the first page of your resume. So if your second page is where you're putting like your projects or some awards or maybe a really cool company you worked for, then I'm a lot less likely to read that second page. I might even miss the fact that you won a hackathon. So 1 page is, you can justify 2 pages with really more like 1.5 pages if you have a lot of experience, but keep in mind that it may not actually be doing you any favors. The one exception I give to this is if you have a PhD and you have a lot of publications or patents, if that's what's pushing you onto 2 pages, that's not a big deal. But a lot of the reason for that is that people don't really read your patents or your publications. They kind of see like block patents, like this little chunk of patents and this chunk of publications. People tend not to really read them. So if that's what's pushing you onto 2 pages, it won't really detract from your resume. But if it's like you're listing a lot of details about your work experience or your projects or whatever, it's probably not actually going to help you. Next thing is use a real resume format. It seems like a stupid little unnecessary thing, but it's actually really valuable. By using specific columns here, first of all, allows you to very quickly, if you look at this resume, you're not going to miss the company names. You're going to see Microsoft. You're going to see Apple. Do I have Apple in there? Yeah. You're going to see Apple. You're going to see Microsoft. And actually, if you look at resumes that are designed differently, you often miss the company names. So use concrete, specific columns for the company names, dates, things like that. The other big benefit of this is if you have 3 columns rather than, some people will just like open up Microsoft, particularly developers do this, like we'll open up Microsoft Word, hit Control-B, type the company name, next line, job title, next line, dates. And it's harder to find the information I want to find. But the other thing is it just takes up so much space. You're spending multiple lines giving these basic facts and having less time as a result to talk about what you've done. Next thing here is short bullets, 1 to 2 lines. Things that are 3 lines or more just, when I only have 15 seconds to spend on your resume, I'm just not likely to read 3 lines of content. Focus on accomplishments and not your responsibilities. So if you go down this list, you probably too blurry from back there, but what you'll see is reduced, implemented, created, built, created, implemented, created, built, created. Think, words like that. Optimized. That's what you want to look for in your resume. You want to have, each bullet be like a very specific, like, here are the 3, think about your bullets when you're making your resume. Here are the 3 biggest impacts I've had. I optimized this, I built this, and I designed this. Oh yeah, and with that also, try, if you can, to quantify stuff. So certainly anytime you have the words reduced and optimized and words like that, things where you're making sort of relative adjustments to something, those should generally be quantified. And in fact, a lot of people will, if I see that you argue a reduced amount of time to do something, but you haven't quantified it, I really question whether or not you actually reduced it, because you would probably have an idea. So try to quantify it. And this also extends to awards. A lot of people really, really don't do their awards justice on their resume. They list, something like the John R. Robinson Award, 2013. And they haven't told me anything about what the award was for, how selective it is. So think about that. Like, how do you make your awards actually really stand out? Tell me something about the selectivity. Because that's what an award is, right? It's award is saying that you are the best or one of the best at something, and I need to know what's that pool size. Okay, GPA, a good rule of thumb, above a 3.0 listed, otherwise skip it. Some people will argue that after you have a lot of experience, it doesn't really matter anymore. It only matters for new grads. That's somewhat true. It matters the most for new grads. But even if you have 5, 10, 15 years of experience, if you have a really good GPA, if you look at how I listed GPA here, it doesn't take up any extra space. So most people won't care about your GPA, but there's a few who will. There's a few who will walk away being like, wow, you had a 3.8. That's a pretty good GPA. And if it doesn't take up any extra space, maybe you list it. Doesn't hurt you. Projects, again, really, really, really important. If you are a software developer, you should hopefully have some projects you've done outside of work. Actually, a lot of people don't, but if you don't, start doing those things. They really help you. And have a project section on your resume. It's really important. If you're just getting started, you're newer to coding, and your work experience isn't as relevant, think about, I've listed projects like this, where I have the project name in bold and then like a 1 or 2 line description. If the bulk of your coding experience is from projects, not from work experience, expand the projects out. Rather than having projects be this like 2 lines per project, have the projects formatted like the work experience is. So have, project name, bullet, bullet, bullet. And with your projects, there's no like rule about such and such can't be, your projects have to be completed, your projects have to have been successful. No rule like that. Any coding works as a project. So any coding that isn't in work experience. If it's part of your job, it goes under work experience. But if it's not, it counts as code. Even if you didn't launch it, even if you didn't finish it. Yeah?
So freelance work would be in employment or under?
So the question is if freelance work is under employment or projects. You can do either. Generally speaking, people would put freelance. Generally speaking, it's going to work to your favor to put freelance work under work experience, particularly if you got paid for it, because it is a job and it shows initiative, and you probably really want to call attention to it. So generally, you're going to want to put freelance work under work experience, but you could kind of justify either.
What if you have like hobbies or something like that? Do you list that under projects too? Like if you modded a game or something?
Yeah. So hobbies. It depends on what the hobby is. The nice thing about being an engineer is that people are really lax about, I know I'll talk about these rules of resumes, but they're really lax. Frankly, most engineers are, so bad with resumes that, like, do what makes your experience look best. So hobbies that are, like, really vague, like running, I run and I ski and I love to travel. That's not, it won't hurt you, but it'll probably just take up space and it probably won't add much to your resume. But if your hobbies are relevant in some way, then think about listing them. So relevance, you mentioned modding a game. That's a really relevant hobby. So do list that, and you could put that under, if you have a real project that came out of it. So you modded a game to do a particular thing. That starts looking more to me like a project. Even if it's not code per se, it still could be a project. So you could list under projects. The other thing is, you can create whatever sections you want. So I have here just work experience, education, and then I have like a technical experience section, where technical experience has projects and languages and technologies. But you can do whatever you want. You could, if you've modded a bunch of games, you could potentially have under technical experience, you could have games that I've modded section. You can do whatever you want. If your hobbies are other things, so one example is somebody who's a product manager and was applying for a product management position at Apple, who had first he was just thinking about listing just running, or he'd run some marathons. And when I worked with him, what I learned was that he had actually signed up for an ultra marathon, which is a 100-mile marathon, which is a ridiculous amount of running. He didn't list it initially because he quit at mile 60, and so he was like, well, I didn't even finish. But first of all, 60 miles is a lot of running. And actually what happened was he quit at mile 60 after getting injured at mile 30. So he ran a marathon, got injured, then was like, you know what I'm going to do? I'm going to go run another marathon right now. So it's not relevant per se to being a product manager in terms of it's not technology related, it's not coding, it's not design related, it's not user focused anything. But it is relevant in the sense of that it shows a lot of persistence, shows initiative to even be doing this sort of training. And so that's a hobby that is actually relevant in its own way if you put it the right way. And so he had additional experience section. So he didn't list it as a hobby, I don't think. I think he had additional experience and listed a couple vaguely interesting things he's done. And one of them was ran 60 miles of a 100-mile ultra marathon after getting injured at mile 30. And sure enough, his interviewer started asking about this because it's a really interesting thing, and it shows a lot of persistence and dedication. So think about your hobbies that way. It's don't list them just to list hobbies. That's usually not that interesting for a software developer. But do list them if there's a way of making them relevant or showing something interesting about yourself. Okay. Last thing here, second to last thing. Technical skills, cut the fluffy stuff. So list your languages. List some of the most relevant, interesting, serious technology you've used, or software you've used. So you can list Visual Studio. You can list Eclipse. Those won't really do you actually that much good unless separate companies that are very, very technology focused. Meaning very focused on you need to know our actual technologies. Google is unlikely to care about knowing this kind of stuff. But some companies that are more really want you to know their technologies will care more. What you don't want to list is Microsoft Office, or things like problem-solving skills or excellent analytical thinker or stuff like that. That just doesn't do you any favors. Okay, last thing here. Objectives they won't hurt you, but the vast majority of times they don't help you, and they actually just take up space in your resume. So if you have an objective in your resume, think through what are you actually saying here? What do you want to accomplish here? If your objective, which is true for the vast majority of objectives, is just a long-winded way of saying I'm applying for a software developer, and then you have some description about at a technology-focused company, which is an exciting position and whatever, that's not helping you at all. So think through what your objective is really trying to do. If you have summaries, similar sort of feedback here, think through what you're really trying to do with your summary. Most summaries are people basically saying things like 15 years of experience as a software developer and blah, 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 and, filed for this many patents or whatever. And it's well, if your resume is this short anyway, your summary isn't helping you. The number of years of experience you have is pretty clear. So, think through your summary. What are you really trying to accomplish? If you are going to do a summary, or you are thinking about it that way, I would encourage you to think about instead having a highlights section, because that's what's really interesting is the highlights, not as much this broad overview. Usually. Okay. So I'm going to move on now to talking a little about behavioral stuff, on sort of like the soft side of the interview before talking about technical things. So really briefly on behavioral questions. So behavioral question is, they're usually things like, tell me about a challenging interaction with a teammate, tell me about the hardest bug you solved, things like that, or the hardest bug you faced. The goal of a behavioral question is 3 things. First of all, answer the question. Secondly, deliver an answer that makes you look good. So if they ask you, tell me about the hardest bug you faced, you want something that's like actually a really interesting hard bug to solve. And then thirdly, you want to communicate well. And this last part's really important because even if you can't deliver an answer that makes you look really good, you can at least deliver an answer that is well structured. So preparation is sort of about the first two of those bullets. It's about how do you deliver an answer that makes you look good. And it's largely about being prepared. So what works really well is to create this sort of preparation grid. So each column is the major chunks of your resume. And so what roles you had, if you did anything like really interesting outside of work, like you ran an ultramarathon, you were the leader of some community theater project, things like that. That's a chunk of your resume. And then each of the rows are the major behavioral questions. So what was challenging, leadership, mistakes, failures, things like that. And go through and fill in this grid. If you have multiple stories under a particular chunk of your resume, so multiple leadership stories, for example, great, list multiple. The main point of this is just to try to help you flesh out a bunch of different stories you could talk about. And then what you want to do is you want to take this grid and boil it down to 5 key stories. So you want to have 5 stories that you're really, really rehearsed on. And those will be sort of your go-to stories when you ask behavioral questions. But it's important to do both of these. So you want to make this grid. It's very, very valuable in and of itself. But then you're also going to use the grid to basically select 5 stories from it. Hopefully most of those 5 stories will give you good coverage on most behavioral questions. But if you're asked things, they won't give you complete coverage. You can still be asked something where none of your pre-prepared stories really fit into those. That's when you're going to sort of fall back on remembering these other stories you thought about. But 5 is a good number to give you pretty good coverage. So go create this grid and create these 5 key stories. The next part is on behavioral stuff is how do you deliver an answer that makes you look good? So there's 2 structures that work really well, and they're actually used in conjunction with each other. So the first one is nugget first, and this means basically that the answer to the question is the first thing out of your mouth. So what accomplishment are you most proud of? I'm most proud of the way I re-architected the file system. Talking about a challenging interaction with a teammate. Sure, let me tell you about the time that a teammate got really frustrated with me for how I delivered feedback. So answer the question is the first thing out of your mouth. And it focuses both you and your interviewer on what you're about to say. For interviewers who have shorter attention spans, or maybe there's a communication barrier in some way, either because you have a very thick accent or they have a very thick accent, or they just don't hear accents well, whatever. It really helps because when you start telling me, I asked you, tell me about a challenging situation you faced on team, and you start telling me the story about, so your manager gave you this assignment, and you had to work with a couple of people, and here's how the different people were interacting. I don't necessarily, you're giving me a lot of information, you're throwing so much information at me. Having this initial thing of okay, I get that this is going to be about ultimately how you screwed up giving feedback, and helps me to kind of file all this information you're giving me. And also makes you less likely to give a lot of unnecessary information because you know that the gist of your story, the point of this whole story is about your teammate getting mad at you. So you know to focus on your teammate and not these other people. If you start answering a question, you find this very difficult. If you can't start off with that first nugget, then you probably don't know exactly where you're going. You should probably stop and make sure that you know what is that nugget. You can't really write a great essay if you don't know what the whole point of your essay is, right? Same thing here. You can't really deliver a great answer if you don't know what the point of it is. So make sure you give that nugget. The second structure, which is usually used in conjunction with the first, is what's called situation action result. And this is basically what it sounds like. You'll also hear it referred to as situation task action result. Basically means talk about the situation, the action, the result. So what I find most people do wrong is, what I find is 2 really common things people do. The first one is particularly big problem with anybody who's in a leadership capacity So managers, product managers, anyone who's a tech lead, people like that tend to have the biggest problem with this. And the issue is that what they do is that they focus far too much on the team and not about themselves. And so you'll hear, I work with a bunch of CEOs through acquisitions who are applying for product management positions. And because when startups get acquired, the CEOs typically get slotted as product managers. So you'll hear these people talk, and they'll say, well, yeah, I say, tell me about a challenge you faced at work. Sure, so, the company was not doing well in this particular way, and so we had to rethink everything. We had to regather some data. It's we. And that's not interesting to me. When someone says we, even if you're the manager, I don't really know I don't care that one of your subordinates was successful doing something. I want to know, what did you do to make that happen? If your employee was successful, but you didn't help drive that, then I only care that your teammate or your subordinate was successful to the extent that you led that. So you need to be very clear about what you did. So you organized a brainstorming session and structured the meeting as follows. Focus on yourself and not you. And this tends to be a big problem with managers because in the workplace they do basically the opposite. They're constantly told it's not about you, it's about your team. In the interview, it is about you, not your team. The other thing that's really common, basically across the board, is that people spend far too much time on the situation, not enough time in the action. The whole point of the story is the action. When you ask, tell me about a challenging interaction with a teammate, it's actually not really about the challenging interaction. It's about how you responded to them. So flesh out that action. Say, I did 3 things to resolve the situation. First of all, I called up our key buyers and gave them a call just because I know that they would appreciate that personal touch to give them that heads up about what was going on. Secondly, I gathered historical data and ran some statistical analyses to get a better prediction for the future. Thirdly, I blah, 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 blah. So flesh out that action, really expand on that. And think about, with these stories, what are you trying to say about yourself? So, if you look at the bullets I just gave you, what I said was something interesting. And I called up the suppliers because I knew that they would appreciate that personal touch. That's actually a more effective statement than saying, I called the buyers and let them know what was going on. I've sort of called out and made sure the interviewer knows, hey, I did this because I think about other people and I think about what they want. It shows a degree of empathy for me. So try to do that in your stories. Try to think about, what are you demonstrating about yourself? Are you demonstrating that you're data-driven? Are you demonstrating that you have empathy? Are you demonstrating that you're a risk taker? Or that you are very methodical? Try to think about, what are you demonstrating and how do you go? You don't want to say, I did this because I'm methodical, but you want to get basically one step away from that. Okay. So now onto the technical side. So technical interview questions are things like, the ones I'm going to talk about today are things like design an algorithm and write code to select a random subset of a set. So the way you want to study, first of all, is focus on basic stuff. Go through and implement the basic data structures and algorithms. Don't worry too much about the really complex algorithms. I'm going to talk a little bit about what these basic data structures are. Don't worry about the really complex ones. Let interview questions be your guide. And that brings me to the second point, which is really practice solving questions. If you see that there's things that you don't know, like you're reading these things and it's telling you to implement a binary search tree with such and such, and you aren't super familiar with binary search trees and how you traverse them and that kind of stuff, yeah, go read that stuff. But don't, what a lot of people mess up on is they go on kind of this wild goose chase through bigger, these huge algorithms textbooks, and it's just so far beyond the complexity of an interview. Remember that your interviewer, one, even at people think Google and Facebook that because they're ask the hardest questions, that this means that they will ask you about that the actual topics will be really hard algorithms, and that's not true. They ask you complex algorithm problem-solving questions with a basic set of knowledge. They don't actually care about knowing if you know how to do these. If you know these more complex things like Dijkstra's algorithm and these more complex things, the interviewers are years out of school. They may not have CS degrees themselves. They're not really caring about focusing about asking you complex sets of knowledge. On the question is really, really push yourself. what you want to do is you want to get yourself in the mindset of solving hard problems. Write code on paper. Super important. In an interview, sometimes particularly at startups, you'll get an actual computer to use, but mostly you're going to be coding on a whiteboard. So there's 2 reasons why it's really important to do this practice. Well, actually 3 reasons. So one is that there's like this, some of you guys might have read some of these like psych, if you've ever taken psych, you might have read some of these stuff about how memory works, how if you're going to take a math test, you'll score a little bit better if you study in the room where the math test is in, because your brain just like makes certain jumps. So it's a little bit of a nice thing there of by studying on paper, you're just going to get more comfortable. You're going to have an easier time remembering information when you're doing a test in a similar way. The other thing is that there's a lot of stuff you may forget, and you may not actually know, and you don't even realize it. So old coworker at Google used to. This is actually a terrible interview question, but he used to ask people, rate yourself on a scale of 1 to 10 in C++. These are for candidates who listed C++ on their resume. So he'd ask them this, and then he'd say, okay, how would you, if they rate themselves as like a 7, 8, or 9, so very, very strong in C++, he'd ask them, okay, implement Hello World. Easy enough. This is literally day 1 of computer science. Implement Hello World. And like of the candidates who thought they were really, really good at C++, like 10% of candidates could actually write Hello World correctly. And this seems amazing to a lot of people because it's like, come on, of course you know how to do that. But you don't, because every time you open up your compiler, you have your code editor, you have like syntax highlighting, you have code completion, you have this like templated code. It's been a while and you haven't really had to think about, is it a left error, was it quotes, is it, what are the return types, what are the parameters? You just forget this stuff. So coding on paper will help you realize the stuff you just don't remember. The other reason why coding on paper is important, this is the 3rd reason, is that when you're coding on a computer, you can be lazy in a lot of ways. One of the ways you can be lazy is you're like, all right, well, I think I figured out the algorithm. I basically know how to do it. And you can just dive into code. And you can just, if you don't get it quite right, you can delete, you can type up 10 lines really quickly. If you don't get it quite right, you can scratch it all, you can edit it, you can move code around. You can't do these things on a whiteboard. So on a whiteboard, because if you think about, you can have a pretty low bar for when you start coding because it's so quick and fast to code. On a whiteboard, it's really, really slow. So your bar for when you start coding has to be a lot higher. And you need to sort of realize how much higher that bar is. So do write code on paper. All right. So I talked about, you need to know basic data structures and algorithms. This is the basic list. So there may be 1 of 2. If you have CS degrees, you probably know most of these words. Maybe you're a little bit fuzzy on some of them, like tries. But you need to know most of these pretty well. A really good exercise, as I said, is to go and implement these from scratch. By far, the most important thing of these is hash tables. Hash tables come up on an incredible number of interview questions. In fact, one way of doing better in interview questions is just have hash tables like the top of your mind. They solve so many interview questions. So you really, interviewers generally won't care that much if you forget whether a linked list uses insert or add or queue or append. But still, it's great to know these things. Hash tables is just so common that you should really, there's just no excuse for getting even like a little bit fuzzy on how to actually use a hash table. So make sure you're comfortable with all of these, implement all these from scratch. It's a really good exercise. And make sure you know exactly what the correct method calls for the hash tables are. Because they're just so probable you're going to need to know them. These are the biggest algorithms you need to know. So I've circled tree and sort of find a depth first search because all of these are really important. But these are the 2 that are ones that you should not only know how they work, but you should be able to code them basically bug-free because they're sort of the easiest of these. So when you walk into an interview, you should be comfortable enough with these that you should be able to code them without any bugs. The other, these 3, quick sort, merge sort, and binary search, you should absolutely know exactly how they work. Go practice them. Realistically, most people, even people who are good enough to get offers, aren't able to code these without any bugs. So I want to be realistic with you guys about that. That if I don't want you guys to beat yourself up over it because you're You practiced writing merge sort and you knew how it worked, but you like had 1 or 2 off by 1 errors. Everybody has some of those. The last one here, breadth first search, is something that if you know what this is, it's very, with most algorithms, if you're a strong coder, you can implement the algorithm if you know how it works. Breadth first search is a funny one where people will know exactly how it works, but just forget how to implement it because it won't, they'll kind of have an idea that breadth first search works by having a node and then you access all the nodes children first and then you access the children of each of those like layer by layer by layer. And then they'll be like, wait, but I can't just like recurse because if I recurse on this one, then I'm going to go through all of its children. How do I get from one child to the next and bounce around like that? People get very confused with it. So most things you'll be able to implement, if you're a strong coder, you'll implement them pretty well if you just understand the algorithm. Breadth first search is the one which a lot of people know how it works conceptually, but just don't know how to implement it because basically they forget to use a queue. So go read over the implementation of that and practice it. And think with each of these algorithms about not only the time complexity, but also the space complexity. Space complexity of algorithms is really important too. Okay. So the concepts, by far the most important thing here is big O time. When you have an algorithm when you design an algorithm in an interview, you're going to have to talk about the efficiency of that algorithm. You really can't do that without really, really understanding big O. So make sure you really, really get that. And a lot of people I would actually say most people who say, yes, I understand it fairly well, actually don't understand it quite well enough. So a test I like to give people is you have the following basic, very, very basic, straightforward algorithm problem. You have, and I know a lot of you guys probably don't know big O at all. That's okay. You can go read up elsewhere. But very straightforward algorithm problem. I'm going to give you. We have 2 arrays, and you want to sum up all the values. 2 arrays of integers. You want to sum up all the values in the 2 arrays. So you can iterate through array 1, take the sum. Iterate through array 2, take the sum. What is the runtime of this? Who says O of n? Okay, a few people. Who say not O of n? Who says not O of n? Anyone? Okay, people who are not raising their hand, or the people who are raising their hand and say it's not O of n are actually the correct ones. And the reason is that you have 2 values. What is n? Is it the first array or is it the second one? So people, and you understand the concept basically. You're saying, well, it's linear, and you're right, it is linear, but it's linear in terms of both arrays, not just one. N has no meaning there because there's 2 arrays. The correct answer is it's O of n plus m or O of a plus b. And that's the test I give people. If you messed up on that, which almost everybody does, by the way, so don't feel bad about yourself, but most people are messing up on this. So make sure you remember these kind of things. If there's multiple inputs, you probably need multiple variables. The other task I give is that if I describe something, suppose I don't know why I would be doing this, but I have an array and I want to, maybe I want to find if there's off the top of my head, I have an array of positive and negative integers. I want to find if there's any value in the array that equals the sum of the array, which is possible if there's positive and negative values. So the array could sum to 10 if there's positive and negative values, and there actually be a 10 in the array. So basic algorithm for this: run through this array, compute the sum, and then go through the array and see if there's any value that equals that sum. If I describe this as O of 2a or O of 2n, you should wince a little bit. If you don't, then that means that you kind of don't totally get O of n, or don't totally get big O time. Because you drop constants. It's very important that you drop constants, actually. And if in an interview situation, when somebody doesn't know this kind of stuff, it seems like these little details, but it's usually a tip-off to interviewers that you're a little bit fuzzy on some of these CS fundamentals. And these are really, really common mistakes. I would say the vast majority of candidates I work with make these mistakes, so that means that most of you, even people who think they're fairly good with it, probably making some of these mistakes. Make sure you're really comfortable with that. Next thing I want to talk about really quickly, recursion. For some people, it's super easy, and they're like, I don't understand why everybody else thinks recursion's hard. It's just a different way of solving a problem, but it's easy. If you're one of those people, great, no worries. just with recursion, remember the space complexity impact of doing recursion. If you are a person who struggles conceptually with recursion, that's very, very normal. You just need to get more practice with it. And with recursion, whether you're whichever type of interviewer or whichever type of candidate you are, think about memoization of recursion. If you have really inefficient recursion problems, you can use basically cache or memo table to speed things up. Okay, so if you don't know this stuff, yeah.
So you said big open. So what about small open?
Yeah. Great question. So I simplified all that. So the question was about, what about, I talked about O of n. What about like omega and theta and all this stuff? So, what? So a funny little thing happens between like algorithms in college, algorithm class in college, and then like the professional world and professional world and interviews. People so there's this concept of big O and theta, and these describe basically upper bound or lower bound on the time. And then suddenly we all get out of algorithms class and forget about all of that, and we start completely misusing the terms. So what people basically mean when they say O of n in the professional world and within interviews is actually what they should be describing as theta. And they just forget about all of this. So I've never seen these concepts of theta ever come up in an interview, unless you have like some really deep background in algorithms. People just forget about all of it and are just wildly misusing the term. So when I say big O, I'm actually really saying theta.
Because big O n square is also big O.
Yeah, and that's the thing with O. O of n cubed. So you could describe an O of n squared algorithm. Technically, according to the official definitions of big O, you could describe an O of n algorithm as O of n squared, because it refers to like an upper bound or lower bound, depending on how you look at it. And yeah, people just misuse the term. So in the interview, in an algorithms class, you're totally right that linear time algorithm you could technically say is O of n squared. In the context of an interview, people just are messing up all the terms, and you should actually be saying O of n, even though it's technically you should be saying theta.
So O of n is always theta when they're asking questions about O of n. You should be answering theta.
Yeah, I mean, just say O of n and just kind of like bite your tongue and be like, bleh. Not quite the right terminology, but yeah, people just misuse the term. And I have a theory, which is that people started all messing up the term because it's a lot easier to type O than theta on a keyboard, which is a possible explanation for why. But yeah, people are just all misusing the term. So you should basically be trying to give the tightest bound on the runtime possible, the most accurate answer. So everyone just using the term O when it really should be theta, but everyone just uses O. Okay, so if you don't know this stuff, which a bunch of people do, there's a lot of resources to do it. It's necessary for the top tier of tech companies. It's not necessarily necessary for all tech companies. So if you're way out of bounds, you don't know any of this stuff, it's not necessary for all tech companies. But it is actually a very useful stuff to know. It really doesn't take that long to learn this stuff. I've worked with a bunch of companies through acquisitions where the people don't have CS degrees, don't really know other than a vague idea of what these different concepts are, and you can actually learn this stuff in a week or two and get pretty well prepared. It's not that hard to do it. But if you don't know it, there's good exercise. I said is go implement all these things from scratch. There's a ton of books. MIT has open courseware. There's a ton of tutorials online. So go learn if you don't. Mm-hmm. Good question. So I'm going to broaden the question a little bit if you don't mind. So the question was about if you do MIT OpenCourseware, if you should put these on your resume. I would actually say yes. Particularly if you have something where it's really a clear class you took. So if you took a class on Coursera or Udemy on algorithms or machine learning, stuff like that, I would actually say yeah. You could put it, depending on your background, how strong your resume is otherwise, you could put it under education. I mean, basically anything you do on your resume that's honest is fine. So you can put it under education, or you can put it under additional experience or additional information. But if you don't have that CS degree, and you're applying for companies that generally hire people with CS degrees, it can actually be pretty valuable to say, like, because one of the things, recruiters, when they pick up your resume, are looking for two things. One is, will you be a good employee? But the other thing they're looking for is, will you even pass the interview? And so when a recruiter is reading your resume and they generally interview people with CS degrees and you don't have one, but you have this, you took this class at Coursera. One, it shows initiative, but two, it means it tells the recruiter that you're more likely to pass the interview.
I'm thinking like algorithms and data structure are one of the courses that inside of CS because they highlight the fact that, oh, this guy really does.
I don't think it does. I mean, certainly if you don't have the CS degree, it's very valuable to show it. But even if you do and you took another class on it, I don't think it really says anything bad. I mean, maybe there's a slight, like, why did he need to take it? But, you did, and that shows initiative, and who knows what the course may have been a deeper dive into it, and that shows, I mean, I think the vast majority of people would see that as a good sign. Okay.
So even if CLRs, like there are like intro chapters, are they important? Because you go to the second half of the book, it is like very.
Yeah, no, the CLRS or any algorithms textbook like that, and this is why I keep talking, like, don't worry about those algorithms books unless you need to relearn the knowledge. But algorithms textbooks are usually just they're a full semester on stuff. It's a lot of material. It's generally not the best way to learn. It's just not a good resource for interview preparation. It's a great way to learn otherwise, but it's not a great interview resource. Unless you find like you don't know anything about graphs. Then maybe, go learn some of the stuff, but I would spend more of your time on interview questions rather than algorithms textbooks. Okay, so now let me go on to how to actually do well in coding algorithms books. Or how to do well in coding algorithm questions. So, a couple things you want to do. First of all, understand the question. You guys have heard this about interview questions a bunch probably. Ask questions, clarify, blah, blah. I'm talking about, yes, do all that, but also make sure you really understand the question. So what I find here is that a lot of people, they'll hear the question but kind of forget certain things. So, as an example, I tell you, design an algorithm to, you're writing a binary tree class, and you're going to, in addition to writing, you're designing this like class from scratch, and in addition to writing a insert and find and those sort of methods, you also want every node to have a method to get the sum of its subtree. How would you design that algorithm? So what I mean by understand the question is, first of all, set it in a kind of confusing way. Make sure you understand what I'm talking about. But secondly, make sure you really got that bit. So think about it. Why did I tell you that? I said, I didn't just say, given a node, compute the sum of all the nodes, compute the node compute the sum of that subtree. I told you specifically, you're writing a method on that node. So I told you in a very specific way that's actually a less intuitive way to state it. So I said did that for a reason. So think about what are those little details that the interviewer is giving you, because those probably you probably cannot design an optimal algorithm without those details. So if I told you the array is sorted, you probably need that information. So think through that. Then draw an example. And I'm going to talk about this in a little bit more detail, but draw an example. It's really, really important. Far too many people, there's something about the shape of an interview room where like I'm sitting here, you're sitting right here, the whiteboard's all the way over there, and people just have this habit of just like staying in their chair. And it's actually a really detrimental thing for them. So get out of your chair and start going to the whiteboard and coding. Or going to the whiteboard and drawing a specific example. I'm going to go into that in a little bit more detail shortly. Then talk out loud, really show your interviewer how you're thinking. Analyze your algorithm. Think about, does it really work? Code, slowly. Take your time. Refactor once you've coded, and then test. Let me go into a couple of these in more detail. One quick thing I want to mention here. If you've heard a question before, admit it. If it's a really obvious question, there's some questions that are so common that I don't even know what it would mean to hear it or not. So an example is write code to reverse a string. That's not it's not really a complex problem solving. That's just really a straightforward coding problem. So I'm not gonna so expect you to tell me that you've heard that problem before, because I think kind of everybody has. But if it's something like a novel problem, so design an algorithm to do this, like to find all instances of a substring within a bigger string. That's a more complex problem-solving question. If you've heard it before, you need to tell me. And the reason is that when I ask you, design an algorithm to find all instances of a substring within a string, I don't care if you know how to do that specific thing. I don't care at all. What I care about is seeing how do you solve problems you haven't seen before. I'm really evaluating your problem-solving skills, not your knowledge of that answer. So if you just hear that problem and you spit out the right answer, I can't evaluate your problem-solving skills if I didn't see them. So at best, the question will just be essentially stricken from the record. But at worst, I'm going to see, as a lot of interviewers do, I'm going to feel that you sort of cheated or dishonest or trying to mislead me, and that's a really bad black mark to have on you. On the flip side, if you tell me that you've heard it before, you heard the question before, I have a lot more respect for you. So do admit it when you've heard a problem before. Okay, I'm going to talk about, examples, analyzing problem solving, and coding and testing in a little more detail. So, examples. This is one,
Last slide, as you said that if you have heard the question, then admit it, right?
Yes.
But when I got the question, put it back on my interview will ask me few other difficult questions which I won't be able to answer. So what practically speaking is?
So so actually it's interesting. If you've heard a problem before, I would say actually about half the time the interviewer asks you to solve it anyway. And the reason is that I've done this a bunch where candidates will tell me they've heard a problem before and ask them to solve it anyway. And I haven't actually found that those candidates do much better on the question in a lot of cases. It depends on the problem. But the reason is that a lot of questions sound similar and they thought they'd asked it before, they'd heard it before, but they really hadn't. Or they've heard it, but they actually totally forget how to do it. So a lot of people will ask it anyway. But they might, after that, they'll move on to other questions. The questions might be harder, or they might be easier. It really depends. They won't necessarily be harder. But again, the alternative is to get reviewed as cheating, and to, if you just spit out the right answer, they'll just think they just see okay, you already knew the answer, and it doesn't mean that you're very good problem solver because they didn't get to see that.
Let's say you get to the first question, you answer, you get to the second question, and you don't agree with the answer to the first question that the recruiter or the interviewer gave you. How do you move on?
Okay, so the question is basically about, what do you do when you disagree with the interviewer? So, disagree gracefully is what I say. So, remember that first of all, two things I want to say is, I've had the candidates disagree with me. Every once in a while they're right, but it's really unusual. And not because I'm necessarily that much better than all the candidates, but because I've asked this question so many times. If you disagree with me, odds are you're wrong. And this is true across the board. If you disagree with your interviewer, understand and respect that I know you're really sure about yourself, but you're probably, most of the time when you disagree with the interviewer, most of you will be wrong. So give your interviewer a little bit of the benefit of the doubt there. And even if you are actually right, you still want to approach it gracefully. So don't necessarily challenge your interviewer directly. Say, that's an interesting perspective. I would have thought about it this way. Can you help me understand why this is wrong? If you still continue to disagree, try to give your interviewer some way in which they're right. So, an example is maybe your interviewer is under the right weighting of things. Think about what's the best way of solving a problem. Under different weightings, different ways can be best. So maybe you care more about time, or more about space, or more about the elegance or simplicity of the code. So maybe your algorithm is faster in terms of time, but uses more space. So you can be okay, if your interviewer had a different one, it's slower but uses less space. You can be yeah, I guess that approach works well. It kind of depends on how much we weight time. If space is really important, then that is a better approach. Or maybe your approach is better in both ways, but you can argue that you can say, oh well, yeah, it really depends on how you approach it. Your way is definitely a lot gives a lot simpler, more readable, more maintainable code. So try to give your interviewer a way out from feeling directly challenged, because people just don't respond that well. But I don't necessarily, that doesn't mean you can't challenge your interviewer, just do it delicately. Just kind of like, think about it like being on your best behavior. Okay. So, examples. I would say, despite doing this, despite talking about this, most people just still do this wrong. So try to really, really, really listen here. Most people's examples are either too small or special cases in some way or other. So what I want you to do when you're coming up with an example, first of all, definitely use an example, but try to basically like debug your example. Think about, is there any way that this is a special case? So let me give you guys an example. Okay, so here's a problem. So I give you two arrays that are both sorted, and I want you to design an algorithm to count the number of elements that the two arrays have in common. So basically compute the intersection, the size of the intersection. So two arrays sorted distinct, count the number of elements they have in common. So a typical example that somebody might do is something like this. Let me give myself a little more space here. So I may do something like this, and then okay. Why is this a bad example? Anyone?
Because the index of the one that you're comparing is the exact same index in the other one.
Yeah, exactly. It's a mild special case, but it is a special case that these are the overlapping elements. Okay, so I'm going to go fix this. So I'm going to go fix this up to not have this problem. Let me make this, let's see here. I'm going to make this 2, 6. Okay. Any other reasons why this is bad?
Same size.
Yeah, same size. So let me, okay, now fix that problem. In fact, I'm gonna say, you know what, fix it even better than this. So let's make this, I'm gonna make them like even more lopsided. Okay, any other way this is a special case?
No duplicates.
There's a duplicate.
No duplicates inside each array. Same array.
Oh, sorry, I told you sorted and distinct. But very good point if it weren't distinct.
There's no empty arrays.
Yeah, I mean that's more of a special case. So that's like stuff that you probably wouldn't design your algorithm around, but you'd want to test before.
There's sort of scale in the same area where one's between 3 and 30, if it's 2 and 4,000, you get a whole different story.
Yeah, it's something to watch out for. The way to think about your example is, imagine you had your completed code. Would you try? You can never write one test case and say, well, it works for this one test case, so it works for all, because that's just not true. But the way to think about having a good example is you want to write an example that is generic enough that it would work for the typical example. So you could trust that, yes, if it works for this example, it'll probably work for the vast majority of cases. Right? So obviously, if two arrays are the same length, you can't say, oh, if they're the same, it works the same length, that it works for all sorts of arrays. Like, well, what if most arrays are not going to be the same length? So you want to think about your example. There's at least one other way that this is a special case.
They're all regular integers and floating.
I'll tell you they're integers.
There's only one match.
Yeah, exactly. There's only one element in common. Think about how easy it would be for your algorithm to have a bug where if you found one duplicate, you wouldn't find the others. And actually, suppose I said, okay, great, let's fix this up to make this. This is still a special case because now I have all the duplicates with like the second array's duplicate ahead of the first one. So you want to try to fix up this kind of stuff. So work with your example and really, really think, is it a good generic example? Yeah.
There is to be sorted.
What?
Sorted arrays.
these are almost like that's no, they're sorted. So this problem I said sorted and distinct. So the arrays should be sorted. Now, if you're writing your actual code, you might want to have some sort of test case maybe to fail completely if you can't assume the arrays are sorted. Yeah.
You can reduce the number of operations. We see this maximum number from the smallest pair.
Yeah, that's a good optimization to make. If it's sorted, so he was saying that this element is smaller than this one, then you can break. Okay, so these are the kind of things you want to look for your example. Think through your example and think, is there any, and try to debug your example, think, is there anything that makes a special case? Yeah.
Yeah, so is it a good idea to talk out your example, like as you're creating it, or to keep that internal?
I mean, it shouldn't, coming up with examples should be relatively quick. I don't think it's super valuable to come up with, I mean, what I would do in this problem is I would, first of all, the other thing I didn't like about this example, it's a little bit on the small side. You want your example to be almost annoyingly large. Not quite annoyingly, but pretty close. So like 4 elements and 6 it's just hard to come up with an example or to come up with find patterns when your examples are really small. So I would do an array like, now note that there's some other special cases here. You might notice like this example, all the elements are different by 5 exactly. It is a special case. It's not the type of special case I'm going to be super concerned about, because unless you do something really weird, it'd be really hard to like accidentally have a bug where it doesn't work if they aren't evenly like spaced out like that. I mean, you have to do something very strange. So that's not the kind of special cases I'm concerned about. I'm concerned more about like the bugs you could easily make, like it only worked with one duplicate or something like that. So I make an example that's more like this. So 5, 3. So I'm going to have one where they're the same. I'm going to have one where they're not, where one's ahead of the other. And then I'm going to have one where it's smaller. And then, maybe like that. So that's that. So, I might even add 1 or 2 more elements here. So it doesn't take super long to come up with a good example once you get used to it. So I don't think you really need to talk through it. You just need to think about it for yourself. And, for you to look at it again, you're like, I don't like this example, just tweak it a little bit. So really, that's one big improvement you can make to your algorithms, is by just coming up with a better example. Okay. If you are coming up with coding, if you are coding, you're coming with examples. Or you are, so moving on from examples to algorithms. A couple things you can do when you're stuck. First of all, relax. Struggling does not mean that you're doing poorly. It just means that you're having trouble solving that problem. It is expected that when you write an algorithm, when you're designing an algorithm, you're not going to just know the answer. That's not the way the interview works. It's about problem solving. So the problem solving is a good chunk of the time in a lot of interviews. So struggling doesn't mean you're doing poorly. Think about, is there any information you haven't used? So when you're trying to come up with an algorithm here, if your algorithm hasn't used the fact that they're sorted, then it's not optimal. 2, in order to come up with an optimal algorithm, you almost certainly need to use that information. Next thing, if you're stuck, try to just come up with a new example. Sometimes that can just get it, you can see things in a slightly different way, see different patterns. Try to solve it poorly. So that can mean either, come up with a brute force, just, even if it's naive, you should really actually get the pattern of like, start with an example, say your brute force, just get a brute force out there. Or you might as well solve it slightly incorrectly. So incorrectly means not necessarily suboptimal, but the algorithm doesn't actually work. So an example is you want to find generate a random subset of an array. So given an array of n elements, return a random subset of k elements. So an incorrect algorithm here would be like, it turns a subset, and it's kind of random, but not fully. So some elements are more likely to get chosen than others. That would be like an incorrect algorithm. Just start with that. Start with anything. And it's important for 2 reasons. First of all, that actually is a good starting point to optimize or fix it up from there. The other reason is that other candidates are doing that. And so when I ask you a question and you are sitting there solving in your head, and you're not telling me what's going on, and you haven't even studied the brute force. As far as I know, you don't actually know a brute force algorithm. Remember, the brute force might be obvious to you, but it's not obvious to all candidates. So as far as I know, you might be actually really not even able to come up with a brute force. So get that brute force out there. Get something as a starting point, so you can start with that, and so that I know that you're at least at that step. Then you can also try tweaking or simplifying it. So let's talk a little bit more about the brute force. So we have this brute force algorithm, and let's suppose you want to find the number of intersecting elements. So one approach that works well is what's called a bud optimization. So this is a really ridiculous algorithm acronym. But what it means is basically to walk through your brute force, really walk through it in excruciating, painful detail, and look for bottlenecks, unnecessary work, or duplicated work. So I'll show you an example of this. Well, so first of all, let's suppose we have a really basic brute force algorithm that says, okay, I'm going to do this by brute force. I'm going to start with 3, look for 3, start with 5, look for 5, start with 10. 10, start with 5. So this gives us an n-squared algorithm. You have 2 inner for loops. Basic algorithm. Okay, so now what I do to optimize it, I walk through my algorithm really slowly. A lot of people get very hand-wavy. I tell them this approach, and they get very hand-wavy. They're like, okay, so 3, search, 5, search. No. Go slowly. I start with 3. And now I look here, 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 here. And then I'm going to go to 5, and I'm going to have a queue here, and I'm going to compare this and this. I'm going to compare this and this and this and this. Go through it really slowly and look for bottlenecks, unnecessary work, and duplicated work. So first of all, bottlenecks. One bottleneck here is that we keep searching. This is a bottleneck in the sense of that if you can optimize the searching part, then that's going to really speed up our algorithm. There's also unnecessary work because we start with 3, and we go here to here to here, but hold on. These are sorted, and we know we're going to have to use that sorted information. These are sorted, and so if we just keep getting bigger and bigger and bigger, we're not going to find an element less than 3, or we're not going to find 3 here once we're already at a bigger element. So this is unnecessary work. So already we can say, okay, here's an optimization. From our initial brute force algorithm, which is n-squared, we have an optimization, which is once we exceed this element that we're on, break. Unfortunately, that's actually still an n-squared algorithm, but it's a little bit, it's a better n-squared in a sense. It's something, we're proving it. But now we keep thinking, okay, I have this optimization now. So I have 5, and I go here to here, here. I have 10, and I'm going to go here, here, here. Well, you might start thinking about, wait a minute. We found 5 here. Isn't it kind of unnecessary? If we know 5 is less than, this element is less than this one. We know this element was here. Isn't it kind of unnecessary to start way back here? And as you start working on this, we'll start getting a more and more optimal algorithm. So look for these things look for any way in which your brute force is doing something unnecessary. Or maybe it was duplicated. Maybe you maybe these aren't duplicates here. Maybe this is sorted, but this one isn't. And maybe you'll find that, you find an intersection and one's sorted, one's not. Maybe the duplicated work is that you're looking for 10 here and you're looking for 10 here. That's a little bit duplicated. We could at least cache something, right? So look for these kind of things. Look for duplicated work, bottlenecks, unnecessary work, and duplicated work. And go through your brute force very, very slowly to do this. Okay. Now into coding. Some simple handwriting stuff. Code the far top left corner. And code, try to write fairly small because you really need the vertical space. But also try to write straight. So what I find is that a lot of people have what I call line creep. So they start writing like this. And it's kind of messy regardless, but it's a particularly big problem if you're working in Python or any language where white space is significant. Because all of a sudden, I can't really tell, this was here and this was over here. Was this part tabbed beneath this one? I don't really know. So try to write small and straight. If you don't erase large bits of code just because you need to insert something above it. Use arrows. It's perfectly fine. Optimize around the fact that handwriting is really, really slow. Use good variable names. Again, this is about optimizing because handwriting is slow. So use a variable name that's int number of children. And then after that, say, hey, I'm just going to abbreviate this as NC. Maybe you can write a little comment next to it to say what the abbreviation is. This way you kind of show, yes, I care about variable names, but I also am going to be reasonable about the fact that it's really, really, really long to write number of children. And then write beautiful code. You have like 10, 15 lines in your whole coding, generally to show that, like, yes, you write good, clean, maintainable code. It's not a lot, and so essentially any mistakes that you make is, you don't have a ton of room to show that you really care about refactoring and good design, all the stuff. So you need to make sure that you demonstrate that in that little bit of code. So try to write beautiful code, and once you're done coding, go and see if is there some way that you can clean it up. Go immediately and just refactor. Don't wait for your interviewer to say that. Go refactor it. And then this approach called breadth-first coding. So breadth-first coding is an approach where you think about modularization from the very beginning. So this means is, take a problem. There's something called the ransom note problem. It was a popular question back when I was at Google, which is basically you have a ransom note, or I'm trying to write a ransom note, and I'm going to cut out characters out of a magazine to build this ransom note. So I'm going to cut out little letters and build a ransom note with it. The question is, given a magazine and given a magazine, given a note, can I build that note with that magazine? Well, what most people will do, I'll tell you what the algorithm is. Basically, go through the ransom note, count how many A's do we need, how many B's, how many C's, how many D's. Then go through our magazine, build a similar table. We have 3 A's and 2 B's and 10 C's, whatever. And then we compare these two character frequency arrays. So typical approach is this sort of thing that people write. So people just go through this line, this. It's okay. But it's not actually the best way of coding it. Instead, do this modularization from the very beginning. So when you see these things that are like, algorithms that are like, seem to be like, step 1 I do this, step 2 I do this, step 3 I do this, or maybe it's, for each element, do this search. Try to modularize this stuff away. And right from the very top left, very top level function from the very beginning. And the reason why it's called breadth-first coding is once you write that first level function, you go one level deeper. So you write this initial thing that's like, build this character build the thing for the ransom note, build the thing for the magazine, compare these. And then the next thing I do is I write this function. I don't, so I go write this function. And then you try to farm off as much work as you can to other functions. So I need a function to, I need some code to convert like an A to a 0, a B to a 1, a C to a 2. I'm just going to punt that off to another function. I'm not going to worry about it yet. The next thing I do is I write this, I don't go, I had this subroutine I used here. I don't go write this one. I go write the next level here. So I go write this is included function. And now I just go, I go level by level, deeper and deeper, until my code is done. But what will actually happen in a lot of cases is your interviewer will actually stop you and say, that's good. Like if I were interviewing you, I wouldn't really need to see this function probably to convert a letter to a number. It's a tedious function if you've written all the other stuff. It's not really that interesting to see. So I'm probably going to actually stop you a lot of times. The other thing it does, shows good coding style. It isolates bugs. So, if you do have a bug go back here. If you do have a bug down here, when it was all one giant function, it feels to the interviewer like that bug just got propagated through your whole code and messed everything up. When it's isolated, it means that I knew exactly what your input and output was supposed to be. And so if this has a bug, it feels like it's just this part works. But the most of the code worked. It was just, you had one little bug in this tiny little, not that interesting function. So it isolates your bugs, which makes it perceived as fewer bugs. And it actually isolates your testing. You can just test this input and output. You don't need to, you can test this input and output separately. You don't necessarily need to test it all at once. Yeah?
Can I propose an improvement to that algorithm?
Yes, there are some improvements. What is it, out of curiosity?
Since the ransom node itself is tiny and the magazines are pretty big, maybe once I build the chart for the ransom node and I start going through the magazine, I don't build the whole thing for the whole dictionary for the magazine. I just decrement the counters in the ransom node. Yeah. So this that is more optimal. This algorithm, I wrote it this way basically to
demonstrate something. But yes, the slightly more optimal way of doing it is to go through the ransom note first, and then figure out how many you need, and then once it's filled, break. So you only actually need one table.
So is the optimization like this, which does not affect the complexity important?
So yeah, that does. I mean,
it's not like it doesn't change the complexity, and you hardly have maybe.
It does actually change the space complexity a little bit. Well, actually, no, it doesn't.
No,
You're right. It doesn't. It doesn't change the space complexity. It doesn't change in big O time. It's still a good thing to do because as an interviewer, I'm trying to evaluate your problem-solving skills.
when you don't have so much time and you're just constrained by time.
I mean, if you came up with, I mean, most interviewers will be pretty happy with either one, but they might say, okay, is there any way you can reduce the space usage a little bit more? And in that case, yeah, it still shows good problem-solving skills. Remember that all of these questions are just a proxy for how good are you at problem-solving. So it still shows good problem-solving skills that you can think of these other ways of doing it, and you can make it even more compact. Does it really matter that much in the end? Not really. Okay. So now testing. So you've written all your code, great. How you want to test? So when people screw up here, so they, I talk a bunch about have a great good example. It's really important, blah blah blah. For testing that, what people screw up is that they do that and then they test their code with the test case, the example they come up with. A good example to come up with an algorithm is a nice big general purpose one. It's not the best thing to initially throw at your test cases. Throw your algorithm, your code at to test it. So instead, do this. First, do a conceptual test. Does it basically make sense? Does the code look like it's doing the right thing? Run it through and kind of say, okay, here's what my code is intending to do. Does this basically work? It's a conceptual test first. Then look for weird-looking code. So did you start your for loop at 1? Did you have something initialized to length -2? Look for things that just look weird. If you started your for loop at 1, you almost certainly did that for a reason, but it's a really good place where you might make a mistake. Then look for sort of hotspots of errors. So look at your boundary conditions, look at any math you had, look for these kind of things. Then run a small test case. Don't run this giant test case. It'll just be really time consuming. Run a small one first. And then if you're pretty good with that, then run some special cases. But this example is usually just going to take the vast majority of times people have bugs in their code. Running this kind of example is just going to be too big. It's just going to take too much time to test it. And it's just going to really delay the process until you find where your bugs are. And then you have to go fix things and you have to retest stuff. Take this kind of approach. It'll make it a lot faster for you to find your bugs. Okay. Now, wrapping up shortly, but some common mistakes people make. They ignore information given. They forget to use examples. They push through code when they're confused. This is a really big one. Before you start coding, you need to understand at a really deep, detail-oriented way what exactly your code is going to do. So I have 2 pointers, and then I make this comparison, and then if this one's bigger than this one, then I move this one, blah, blah, blah. You walk through your example in detail. And don't just jump into coding if you don't know exactly what you're doing. And if you find yourself kind of getting confused when you're coding, you're sort of slowing down, you're thinking through things a bunch more, maybe you want to go back to your example and walk through it again. Make sure you really get what you're doing. But don't focus on completing your code if you're even moderately confused. The other mistake people do is they just dive into code. They hear a problem, come up with a solution, and then they start coding it. And they haven't actually gotten this sort of implicit sign-off from the interviewer that they're actually at an optimal algorithm they should code. Make sure you don't want to waste your time coding something that isn't optimal. And then they make all these little details. Off by 1 errors, less and less than equal to, people mess up a bunch, little math errors, things like that. So remember these kind of mistakes. They're very, very common. And then I want to leave you with this, which is that, and I want to sort of leave you with this reminder. Evaluation is relative. You're going to read interview questions, and you're going to, from Cracking the Code interview or elsewhere, and they're going to seem really complex. And you're going to read them, and you're going to be like, I don't know how to solve this. That is what every person is thinking. You're not expected to just know how to solve these problems. Work through them and try to get better and better at solving them, but you're not expected to just hear them and know a solution. Nobody can do that. And again, relax. Interviews are supposed to be hard. Everybody's making mistakes. It is very rare, even for candidates, even for the best candidates to get hired, it is very, very, very rare to have someone hear a question and know how to solve it off the bat. Very, very rare. And it's even rarer for that person to be able to code it flawlessly. Everybody's making a bunch of mistakes. And in fact, when you're walking out of your interview and you think, I did really poorly because I struggled with this problem, there is actually no correlation with how you think you did and how you actually did. So you think, I did really poorly in this interview. This one person really didn't like me. Honestly, I've seen this over and over again. Your perception of how you did is based on how much you struggled, which, again, it's like, you imagine you have a class that's curved in college. And if you have classes that curve, you probably have professors who've done, if you have a bunch of classes that curve, you probably have professors which have done this. You pass back all the exams, you ask, you see your grade of 55, you ask your professor, they tell you it's out of 80. And you're like, yeah, but well, what's the average? 55 could be a failing grade, it could be an A. It really depends on what the average is. It's kind of the same way in an interview where when you think you didn't do well because you think you struggled, that's like you saw your 55, but you don't know if the average is like a 30 or 80. So you need to know that in order to know how you perform, and you obviously don't have that information. The other reason why people think they did poorly is they try to read the interview and they try to be like, well, the interviewer seemed happy with my solution, or they never seemed happy with it. Maybe they tell you that was pretty good. That's pretty good. Let's move on to a new problem. Or they told they didn't give any positive feedback the entire time. They seemed unhappy with everything you did. That has nothing to do with your performance. Interviewers are pretty consistent with how they treat candidates, regardless of your performance. So if I'm a nice, upbeat interviewer, I'm going to be nice and upbeat to everybody. If I'm just not that person, I'm going to be that way with anybody. In fact, a lot of interviewers, when an interviewer whose personality does vary across interviews, they often actually seem more unhappy the better you're doing. Because when you're doing well, I'm going to be like, when you're doing poorly, flip this around. When you're doing poorly, at some point it's like, this is a lost cause. You're not going to, all I want to do is I want to finish up this interview. I want to just be, not to be super aggressive, and I want to make sure you feel good because you've got friends. I'm not going to hire you, but you've got friends. So I might actually be a lot nicer to you because you're doing poorly. And when you're doing better, I want to see how well can you do. How good are you? And I'm going to really push you. That's how a lot of interviewers act. So you're feeling someone's unhappy with you or you struggled. Honestly, there's no correlation with that and actual performance. So remember that when you're walking out of the interview, but also remember that when you're in the interview, because you don't want to get into this vicious cycle of I did poorly, and so now I'm doing poorly, so now I'm nervous, and now I'm doing worse and worse and worse. Because it obviously doesn't help you, but it's also not even very accurate. Okay, so just remember that interviews are hard. Don't know how you're doing during the interview or afterwards, and just try to relax, do your best, and remember that there's a lot of randomness in this. Good candidates will do poorly sometimes. Good employees will do poorly in an interview and not get an offer, and actually reapply 6 months or a year later and get offers. I worked with a ton of people at Google who got rejected the first time around because there's just a certain amount of randomness in the process. Okay, with that, I want to open up to any questions.
Do you enjoy interviews?
Yes. Yeah. So I'll say this. I do enjoy them now. At Google, they got really annoying because we had to spend so long writing written feedback, and there was just a huge distraction. The interviewing itself, I like. A lot of people don't, though. I like them because they're algorithm fun problem solving, and yeah. I also really like teaching, so it's it kind of fits in with well with that.
I really would like to thank you for the book.
Thank you.
For the Cracking the Coding interview. Do you mind if I steal a minute of your talk and tell everybody about my meetup that started off your book? It's just
sure. Very, very quickly though.
I'll just write the link. It's on meetup.com. Mock interviews, and I was hoping you would bring up that topic. We just meet and do mock interviews because when I read your book, I thought, okay, I can do this. I can prepare for an interview in 1 year, and but I wasn't sure about how to do mock interviews, and I kind of wanted to do it with strangers and new people all the time. So I started this meetup group, and we just get together and interview each other.
Yeah, so that's a good resources. And actually, it's a good point to bring up, because one good way of interviewers at these top tech companies, they're really not told anything special. Like, there's no like magic secret sauce that goes into interview training. Like, they're just random people who went through the interview process, and then they're given a little bit of training. But I mean, a lot of the training they give is like legal stuff, like don't ask if they're married, and then they'll just throw into your room. So like, there's nothing that really stops you and your friend from meeting together and just doing mock interviews. And if you are particularly somebody who gets nervous or something in an interview, it's actually a good practice to go through to actually start interviewing people yourself, because you'll start to see that like you'll see it from the other side and see that it's not really that scary.
Been speaking about how interviews are conducted and how to do well under those circumstances. Do you have any thoughts on how it can be improved? Like, these are like the famous interview questions that if you Google interview questions, these are done, but not necessarily that's the best way to interview.
So it's a much longer topic. My short response to that is these questions are one way of doing things. They're okay as far as testing people's problem-solving skills, with the understanding that people who do well on these questions are rarely, they're almost always pretty smart. However, there's a lot of, it's biased towards having false negatives and not false positives. So it's biased towards an understanding that it's better to reject good candidates than to hire bad ones. And in the right company environment, where you really want people who are really great problem solvers, where you don't care much about their current technologies, it works, it's a decent process. And that's the kind of the case at like Google and Facebook, because you can come in and you can be great and you can code things really fast and sharp environment because you know these technologies really well and you know about all the other resources out there. When you join Google or Facebook or one of these companies, there's so much internal infrastructure that you don't know. So when you know all these external resources, you can't necessarily access these, and you're going to be missing so much internal knowledge anyway that it doesn't give you that much of a leg up to have all this other experience. So it works okay in Google's environment, Facebook's environment, companies like that, because of what they're looking for, which is great problem solvers. Do a lot of great people get rejected? Absolutely. There's plenty of other ways of interviewing. There's coding. There's some people do these same sort of things, but they do them on computers. Some people give you projects to work on at home. There's a lot of different ways. Nothing is the best. There's ways that are better and worse for certain types of environment. For any environment, any interview type you throw at it, there's ways in which it's flawed.
Do you mind if I make announcements about my company and how it's hiring?
Let's actually not do company announcements.
Okay, that's fine.
Yeah.
Could you go over really quickly the example that you gave at the beginning when you had 2 arrays and a bunch of us thought it was big O of n time, and then you said it was big O of n plus n time?
Yeah, so that's basically this example. So the question was to go over this example again with people saying it's O of n. And I said it's not really O of n. So this is array A, this is array B. There is an approach that basically, or let's suppose this is just, we want to find the sum of both arrays together. So most people said it's O of n. When you say something's O of n, the question is, what does n mean? If you say it's O of n, this is accurate if you say O of n where n equals a plus b, or the size of a plus the size of b. But when you say O of n or n squared, or suppose I'm talking about a binary tree, and you tell me that finding a node, it is actually you have a binary search tree. What's the runtime? What's the time to insert a node into a binary search tree? Suppose it's a balanced tree. Log of n. Well, yes, if n is the size, is the number of nodes in the tree. You could also say it's O of n, where n is the height of the tree. Right? Like, you can't just use a variable without defining what that variable means. Now, in a lot of cases, it's obvious. When you talk about binary search trees and you say n, I know that you mean the number of nodes in the tree. That's like what unless you define it otherwise, you mean the number of nodes in the tree. In this case, when you say n, it's a little bit like, well, n which one's n? Is n a? Is n the first array? Is it the second array? Or is it the sum of the two arrays? There's some, the number of elements in both. And that's why it's misleading or confusing to say O of n. You either need to define what n means, or say it's the size of, if a is the size of a, b is the size of b, it's O of a plus b. And that's one thing I want to leave you with, is that you can't talk about runtime unless you define your variables. And usually you're going to need multiple variables to describe what the runtime is when you have multiple inputs.
You mentioned that the slides were available. What other website is it?
It's go to technologywoman.com, click speaking engagements, and then do Control F for master slide deck, or just for master, and you'll find it.
When the technical recruiter is asking you interview questions, and you have to write a code on the whiteboard, they're not asking for sorting or searching like that. They might be looking for something more complex puzzles. So, what kind of puzzles they ask? Can you elaborate on that?
Yeah, I mean the kind of questions they might ask. So this is one question on the slightly easier side, which is count the number of elements in common. They might, questions that I would ask might be design an algorithm to return a random node from a binary tree. They could ask, given a binary search tree, find all paths of some to a particular value. Huge range.
Usually, some companies have code review as a part of the interview process. So, do you have some references or pointers where you can practice code review?
So if they do code review, so some companies do, some companies don't. It really depends. Google, the biggest tech companies tend not to do code review, but some of the startups or like non-tech companies or like the next or tier tech companies will do that. I think the best thing to do is send your code to friends. Just get used to what sort of things they're going to ask you, read through Google style guidelines is one place to start. Look at what Google recommends. And the reason I say Google is Google has published the style guidelines, and they're fairly widely adopted across industry. Not universally at all, but it's one set of style guidelines. It's a pretty good one. There's no best one really, but it's a pretty good one. So you can read those, and then just do code review with friends. Send your code to a friend. Ask them how you clean it up. Let me take one more question.
What about system design questions? There is always one item.
Yeah, so I didn't go through them in the interest of time, but I do have it actually in the master slide deck. So system design questions. Approach is basically the following. First of all, make sure you understand what the problem is. Ask a bunch of questions. Make a list of kind of the bigger components of the problem. Of the thing. So designing Google Maps, well, you can have this data store, you can have this thing, ask questions. Figure out what the scope of the problem is. So what are you doing with Google Maps? Are you going to have traffic data? Are you going to have reviews for restaurants in there? Is it just routing? Kind of figure out what these different use cases you have to do. Then figure out what are the different components. So you have a data store, these sort of things. And then talk to your interviewer about where they want you to start. Or if they don't give you guidance, think about what are the biggest bottlenecks in the system. What are the challenges the system's going to have? Is it going to be about adding a lot of data? Is it going to be routing multiple people at once? And sort of localize on a problem, then try to solve that one. Okay, so let me wrap up here. And if any of you guys have my book here and you want me to sign it, you're welcome to do that. Okay, and that's all I have. Thank you.